Let's compute another double integral. In this problem, we're going to compute a volume again to get some more practice with that. So here what we have is computing the volume for the function f of xy, 4 minus x minus y. So that's the ceiling, so to speak, bounded above by this function and below by this region. Now you'll notice that the surface here is just a plane. So we're getting one of these triangular solids, and of course the region here is triangular also. So what's nice about the double integral is that the geometric interpretations are very beautiful and very elegant and are very helpful when you take physics and engineering classes. So let's learn how to do this now so when you need it later you'll be able to depend on it. So by the definition, we have the volume to be the integral over r of the function f of xy. And again, we note that this particular function here is non-negative on this region. That's what makes this definition work. And now what we have, we just simply substitute everything in. We'll go ahead and work with this order. I think it'll be okay. So we're going to have the outer integral with respect to x, 0 to 4, and the inner integral from 0 to 4 minus x for the y integration. And of course our function is 4 minus x minus y. And what's interesting about this integral is it has some really neat algebra that you really wouldn't expect, but maybe you do since you see the 4 minus x and the 4 minus x here. So we have a polynomial in x and y, so we integrate with respect to y, so we just get a 4y, a negative xy, and then of course a minus y squared over 2, because basically the 4 and the x are constants relative to y, and we get what we would get in the Calculus 1 class. And now, before we actually use the fundamental theorem here, I thought I might just go ahead and do a little bit of algebra first. Notice we have a y in every term, and of course we have this 1/2 that's somewhat in the way. So let's factor a 1/2 times y here, and then of course with the terms that remain, we have a 4 minus an x multiplied by 2 to compensate for the 1/2, and then of course we're left with the minus y here because we factored the 1/2 y. So everything works out nicely algebraically. And now we can go ahead and substitute. But let's make an observation. Notice when we replace y with 0, that just zeroes out the integrand, so we don't have to worry about that. So we'll go ahead and replace with y with 4 minus x. So bring the 1/2 out, again, another property of the double integral, and we'll have a 4 minus x here in place of y, and then the 2 times 4 minus x is already there, and then of course y gets replaced with 4 minus x. So it's like we have like 2 minus 1. Okay, you have 2 copies of 4 minus x and you take away a copy of 4 minus x. So that leaves you 4 minus x. So this algebra is really unique. And so of course now we have 2 copies of 4 minus x and we just have this. And so that's a very simple integral. But again, back in our Algebra 1 class, 4 minus x quantity squared is certainly equivalent to x minus 4 squared since we're squaring the expression. So I'm going to go ahead and use that. And then of course now this is a very simple integral. The x minus 4 upon differentiation is just 1. So this is just add 1 divided by the new power. So we get the 1/2 that we already have, and of course the 1/3 and x minus 4 raised to the 3rd power. And then we evaluate upper limit 4, lower limit 0. Of course, when we replace x with 4, we have 0 here. And if you like, that bothers you, let me go ahead and put in 3 as the power. 0 cubed is certainly 0, but I shouldn't have left that out. And then, of course, when we replace x with 0 here, we're going to have a negative 4 cubed. And so, of course, now that'll be a negative quantity when we cube it. And then, of course, the additive inverse out here will make this positive. So that's really good. I mean, we want volumes to have be represented by positive numbers. And so now when we notice here, this is just basically 4 times 4 squared. Since we have a 2 downstairs, the 2 will absorb into the 4 to give us a 2. 2 times the 16 is 32. And so the volume of our triangular solid is 32 over 3 cubic units. And we are done.